My name is Ilia. I will today walk you through kind of the basics of operating on ExoGENI testbed. ExoGENI is part of the GENI Federation. The purpose of the tutorial today is basically to show some basic steps you need to take in order to use ExoGENI, kind of acquaint you with the ExoGENI ecosystem of tools and show you some of the unique things that ExoGENI does. The tools that you can use with ExoGENI vary. We have our own set of tools that are usable only with ExoGENI, and that's what we're focusing on today. Also, the standard GENI tools like Omni work on ExoGENI, but for that you don't have to come to this tutorial. You can just come to an Omni tutorial and learn how to use it. Okay, who needs credentials? People are walking in. Who needs? Are you taking? Okay. Here you go. Please sign it when you get a chance. Okay, well, the people who just walked in, you need credentials. Can you share? Because we're starting to run out. For those who just walked in, let me just flash this slide. If you are taking the GIME tutorial tomorrow, I suggest that you snapshot your virtual machine right now, because we're going to make some changes to it which will make it difficult for you to do the GIME tutorial tomorrow. Right? Otherwise, you can always just delete it and re-import the fresh copy. Okay, so tutorial is structured along several lines. It's hands-on, but I'll keep talking through some of the. Would you like set of credentials? And you have to sign this very long form. We'll talk about the native Orca tools, the flukes. We'll talk about virtual machine images and ExoGENI, and there are URLs interspersed through the through this document, and it's meant for you to be a reference point. So if you want to start using ExoGENI on your own, you can always go back to this document and look things up. The tutorial page is over there, so if you don't mind opening Firefox and go into this page, you can find it from the agenda, the GEC agenda. If you go to groups, if you go to groups.geni.net and then find GEC15, click on the agenda, and scroll down to the ExoGENI tutorial, you will find it. Huh? Yeah, okay. Let's see, how many? I'm starting to run low on the credentials. How many of you can share? You can share? Excellent. We also may be running low on resources. ExoGENI is still only, really in reality, only 3 racks. For now. Okay, so let's begin. Let's please open the browser on the tutorial page. Has everyone found the tutorial page? Is there, or rather, I should be asking negative questions. Is there anyone who has not found the tutorial page yet? I don't see any raised hands. So, by the way, there are helpers here in the audience with us. There is Victor Arlikowski in the back, and Mike Zink, and Kong. They are experienced users of ExoGENI, and when you have questions, please raise your hand, and somebody will come up and help you. Okay? So let's begin. The goals of the tutorial are gain basic understanding of ExoGENI, gain the basic ExoGENI architecture, gain a basic understanding of the tools, learn how to build a variety of slices within the rack, between racks, link to mesoscale OpenFlow deployments. Caveat up front, this is a complex distributed system and there are no guarantees. At least one of you will have a failed slice. We'll try again and we'll get it to succeed. Don't worry about it. Let's start with configuring your environment. So now you should launch your virtual machine and log into it using, this is an old password, excuse me, GEC15 user. My apologies. So the password to your virtual machine is GEC15 user. You've been given the little slips of paper Those are your identities for today for operating on ExoGENI. You should not have a number above 30 or below 2. I have number 1. So if you have a credential that says, give me 35, let me know and I will exchange it. No, it's just we have more pieces of paper than we have actual credentials. There are 30 sets of credentials and I have number 1. Everyone else should have 2 through 30. Okay? Now, we are presumably logging into our virtual machines. As I said, the username is GENI user and the password is GEC15 user, not 14. This is a typo. Is there anyone who has not logged into their virtual machine yet? Okay, good. So what we're going to do now is configure our environment, and in the tutorial page, let's just look at it really quick. In the tutorial page, there are instructions on what we need to do. We're going to use a command gedit on the file flux.properties. We're going to open it up. If you want to use Vim or Emacs, you're welcome. gedit tends to be the most natural editor to use for most people who are not experienced developers themselves. And we're going to modify a couple of properties. So this file modifies the behavior of Flux, the tool that we're going to be using, and you need to do it before you launch the tool itself. And so what we're going to do, we're going to modify the environment. We're going to launch the tool. Because it is a web-based Java tool, it takes a little bit of time to download and start up. So while it's starting up, I'll keep talking. So we need to do the following. We need to replace this line in the file. And if you have this page open in your browser, you should be able to cut and paste. We need to replace it with this line. And I apologize, it doesn't all fit in there. Let me see if this will do it. Yeah, there we go. And also, you need to replace these 3 lines with these 3 lines. Now, keep in mind that XX here indicates the number that you have on a little piece of paper. So if I gave you a number that says, give me 05, replace XX with 05. If I gave you a number that says 15 or 16, replace with 16. There are 6 places where you need to do this. 2 in each line. 1, 2, 3, 4, 5, 6. Now, we could have simplified. In fact, in the GIME tutorial, they have a script that sets it up for you. We're intentionally going through this process so that you understand what is actually being done for you here, such that when you start using the tools on your own, you understand the impact of these different settings. All right, so open this in your browser and just follow these instructions. 6 times replace XX with the number that's on the piece of paper that was given to you. Give me something. I will go back to the presentation. As soon as you're done editing, you can make sure you save the file, and then double click on the FluxJNLP icon that should be on your desktop to launch the tool. It will actually do nothing at first. You won't see it, but in the background it will actually load the Java application that is Flux. Is there anyone who is having trouble at this point? Okay. Let me just note right now that for the purposes of speeding up the tutorial, we have skipped a number of important steps that you will have to go through if you want to use ExoGENI on your own. First of all, the GENI credentials that you need to use in order to use the testbed have been pre-generated for you in the form of these little slips of paper. And the credentials are loaded onto the virtual machine that was given to you. These credentials cannot be used beyond tomorrow, right? They're there only for the tutorial. When you want to use ExoGENI on your own, you have to request your own credentials from the GPO. Second, there's a step required for converting those credentials into a Flux-compatible form. The ExoGENI wiki, to which we have multiple pointers throughout this document, will point you how to do it. There's even a video. And finally, you have to sign up to a users list dedicated to the ExoGENI users in order to report problems, discuss your projects with the operations staff, etc., etc. So we're doing none of this today because we're limited in time. Another caveat, keys and credentials. People tend to get very easily confused with the keys and credentials that are used in GENI. With ExoGENI, there are two basic sets of credentials that make it work. There is the X509 signed certificate that you get from the GPO, and it has a password to protect your private key inside that certificate. And it's typically given to you in the form of a .pem file, a file with extension .pem. For Flukes, you will have to convert it to a .jks file. Sometimes you can use .p12 file, and so etc., etc. These are all forms of the same type of credential that confirms your identity to the testbed. There are also SSH keys, private and public, that are used to help you log into the nodes that you provision. Again, there is a public key and a private key. There is no no identity actually associated with it per se, not public one anyways. And the private key may be locked with a password. We're going to be using both of those passwords today. And the password locking both your private key inside the certificate and the password locking your SSH key is the same, just for simplicity. It is that string that you see given on your slip of paper where XX needs to be replaced with a number that corresponds to your credentials. So if you're GIMI05, then your password is G5C7R hash. Oh, okay, the password actually is spelled out. Never mind. You know, I thought that they, never mind. You just use that password. So this password is used for both SSH and the certificate. They don't have to be the same. They just happen to be the same. So please keep that in mind. So let's talk about the ExoGENI ecosystem. At this point, has everyone double-clicked on Flukes JNLP and have it launching? It should pop up a window that...
We were supposed to edit the .flukes.properties, correct?
Yes, before. If... Huh?
Does not look right here on this particular user.
Okay.
I'm not sure we have the right VDI.
The right what?
I'm not sure we have the right image over here.
Okay, well, we have this one. Just use this.
Okay.
That should work. If I toss it, will you catch it? Excellent. Okay, is there anyone else? Please speak up. Don't be embarrassed that you may be having problems. This is all new. There's a lot of it new to you, so just raise your hand.
I came in a few minutes late, so I don't have any to start up stuff.
I'm sorry?
I said,
Okay. First of all, what is ExoGENI? ExoGENI consists of, will consist when it's complete out of 14 racks built out of IBM hardware. Each has 10 worker nodes. Some of them are dedicated to be bare metal workers. Some of them are dedicated to be virtual machine worker nodes on which you stand up virtual machines. Those are the ones we're actually going to be using today. We're not going to be using bare metal nodes because they take about 15 minutes to boot up. There is an open flow switch in each rack, and there's a sliverable storage. Each rack basically represents a small network cloud. We run OpenStack and XCAT underneath, and our federation layer on top of it, called Orca, essentially operates on top of those two cloud platforms. And we also operate a number of network providers to provide you connectivity between the racks. So you can stand up slices both inside individual racks or between the racks. Today the status is we have 3 racks deployed, one at RENCI, North Carolina, one at GPO in Massachusetts, and one at NICTA, down under. 2 racks have been delivered and are being prepped, one here in Houston and the other at Florida International University. And the racks use different layer 2 fabrics in order to be connected together into a kind of connected whole. We work hard to provide slice isolation in ExoGENI. Our goal is a strong performance isolation. We use KVM-based virtualization for virtual machine, and of course bare metal nodes are bare metal nodes. And VLANs are used for connectivity. We don't over-provision the cores when we schedule. So if you ask for a certain number of cores for a VM, you get those cores, and they're yours. We won't overschedule it. The VLANs, technically you can specify quality of service parameters on them. It doesn't work on every rack yet because of some hardware limitations, but we're working to remedy it actually in about a month or so. Orca, as I said, is the federation layer. Do you guys need a set of credentials? Excuse me?
No.
No? Okay, you're just watching? All right. So Orca is the software that actually orchestrates the racks together. It was developed by Professor Jeff Chase and his students at Duke. It was funded as a control framework candidate for GENI, and now it basically is in operation on ExoGENI. Orca exposes multiple interfaces to the users. There's a standard GENI AM API interface, which you can use through Omni and should be able to soon use it through FLAC. It also exposes a native Orca interface, which is what we'll be using today through the tool called Flux. Don't confuse the two. They sound sort of alike, Flux, FLAC, but they actually do quite different things, or in different test beds anyways. One of the unique features of ExoGENI is that Experimenter can operate on individual racks as independent aggregates, as maybe some of you are used to, but you can also operate on the entire test bed, entire distributed test bed, as if it were a single aggregate, and link elements of racks together. A little bit of architectural speak. Each rack runs its own Orca actor called ASM, the service manager, that exposes those APIs. And you can speak to either individual racks, or you can speak to a special SM called ExoSM that has global visibility into both the resources within each rack as well as the network resources connecting to them. The ExoSM URL is indicated there. It's also, the rack SMs are listed on this wiki page, so if you're interested in talking to individual racks, you can always look it up. This is kind of the architectural view of how things are deployed. There's two racks, 1 and 2, rack A, rack B. Each one of them has an SM to which you can talk to if you want to create slices just inside each rack. If you want to create slices between racks, you talk to ExoSM. Today we primarily will be talking to ExoSM, although we might do some load balancing, and some of you will get a chance to create slices down under. The resources are split between these different SMs, typically in about 50-50 fashion. Although bare metals nodes, because they're so sparse and they're typically most useful in inter-rack scenarios, they can only be seen and provisioned through the ExoSM. And of course, all the links, as I said, can be all the links between the racks are visible only through ExoSM. So the reasons to use ExoSM if you're starting up, it's simplicity. You don't have to think about which rack to even use, because if you don't bind your request to a particular rack, the system will find available resources for you. If you want to do inter-rack slices, that's a must. If you want to do bare metal nodes, again, you have to use the ExoSM. And this is true regardless of which tool you use, whether Flux or Omni. That doesn't matter. Reasons to use a rack SM. Maybe you want to start a slice that's just inside one rack, and ExoSM is telling you there are no resources because it has run out of its own pool of resources. Then you can go to the particular rack and try to provision there and find available resources that way. Now we're getting to the section where we start playing with Flux. Has Flux launched for everyone, or is it still downloading? It's downloading? Okay, it may take a little bit of time. Well, are there any questions? I can answer questions for now. We should actually, it should download pretty quickly, but if you have questions, I'm happy to answer it now.
So I also attended the master ExoGENI tutorial.
Mm-hmm.
What's the difference this time?
Not a lot. No. This is a basic tutorial on ExoGENI. If you want to know the kind of more advanced features, I suggest you attend the GIME tutorial tomorrow. I mean, we've made some updates to the tools, but they're not so drastic that you wouldn't recognize them. Oh, right here. Oh, okay. Here you go. Yep. So raise your hand if Flux has launched for you. All right, good. This is making progress. The reason for it is twofold. One is probably bandwidth. We're all trying to download this fairly large application from online, and the other is virtual machines aren't the fastest because you have Java virtual machine running inside a virtual machine, and it's just, it gets a bit slow. So there are reasons for why we did it that way instead of developing a standalone application. This technology called Java Web Start allows us to essentially update the application without telling you. And anytime you start, Java will go and check whether you have the latest version, and if you don't, it will download the new one. So this waiting time usually is really involved the first time you download it. If we don't change it for a while, next time it'll start up a lot quicker. But that way we avoid questions of are you running the right version, and you know, we don't have to coordinate deployments. Basically, anytime you double click on this JNLP file, Java will launch the latest version of Flux for you. So in this section, we're going to talk about sort of the Flux GUI, the various things that you can create, the nodes, node groups, various types of links, the different level of options that you get on for particular resources versus for the entire reservation for the slice. We'll kind of play around with building slice request topologies, and then eventually launch slice requests and log into our slices and see what came out. This page contains the pointer to the permanent stable version of Flux. If you're just working on your own, you can always go there and download it. Some operating systems are friendly, and when you download the file, you can just double click on it and it will launch it for you. If that doesn't happen, but you have to have Java installed, obviously, and we recommend Oracle Java 6. Then you can launch it from the command line by saying Java WS and then the name of the file, and that will launch it as well. So, common questions: can I use Flux outside of ExoGENI? No, you can't. Can I use Genie tools with ExoGENI? Yes, you can. And there are references within this page, again, where you can find some more information about it. So who does not have Flux running yet? Oh, it's a lot. Okay. Bandwidth.
50%.
Okay. It'll go. It'll go. I mean, I don't think there's a restriction on the other end. On the other end, there's a pretty big machine that streams these. I think it's.
I think it's probably more the wireless.
I think it is the wireless. Well, that's why I wanted to do it up front, so that it doesn't take quite as long, or so we get a chance to do it.
I can barely load web pages right now.
Let me continue talking, and as Flux starts, feel free to, when it starts up, you will see the request pane first, and feel free to start drawing on it. You can click to place a node, to change the type of the thing that you place there. There are buttons on top. You can add nodes, node groups, broadcast links. So feel free to just kind of play around, link them together. What we'll do is we'll first just play around with the interface, and then we'll wipe out what you drew and just draw new slices, and then we'll launch them, okay? So let's see. Basically, there are 3 tabs in the view. There's the resources, there's the request, and the manifest tab. It launches in the request tab because that's typically where you want to start. You want to start drawing your slice. The manifest tab is used to explore your slice as they are provisioned. There are various menu options that you should be able to free to explore. As I said, the basic. Let me see if I can start it here. Will it work for me? I'm just going to see if I can launch it quicker here because I have run it before, and it should just basically validate that I have the same version and then let it go. All elements within the request pane, you can right-click on them and inspect their settings, and there is usually an edit properties option. Oh, hang on 1 second, did it just launch? 1 second, please. Okay, mine launched at least, so I can talk and show. So this is what you will see when it launches, right? There's the resource view, the request view, the manifest view. We'll start with the request view. You can add some number of nodes. You can link them together in some topology. You can add a node group or two. Node groups are basically groups of equivalently configured nodes, so like a cluster. Otherwise, they're just like nodes. You can add a broadcast link. So what I just did was, if we talk about what I'm actually trying to do, a node group with a broadcast link in the background like this is basically a cluster with a backplane. All right, I can have more backplanes than if I wanted to. Really, I don't know why, but I could do that. If you right-click on the link itself, you can also choose the option to delete, as you saw. If I go here and say edit properties, I get this window which allows me to kind of adjust the behavior of this resource that I want. So I can select the type of node. Here's the bare metal type, but as I said, we won't be using that today. These conform to kind of the EC2 standard taxonomy of types, and you can look up on the wiki, on the ExoGENI wiki, what they actually mean. The meanings of how much memory, disk, and CPUs you get are actually not the same as what you get with EC2. Here you can select the image that you would like to boot. Here you can select the binding of this resource. You can leave it unbound. You can actually select the boot dependencies for the elements. So if you have a need for parts of the slice to boot before other parts of the slice for a variety of reasons, you can indicate that here. And you can specify the IP addresses. So as you can see, that says link 2 and link 0. And this is node properties of node 0. This is node 0, right? So it's got two incident links, link 0 and link 2. So if I want to put an IP address on an interface on that node on link 2, I can say, 172.16.1.1 or .2.1, let's say. So this is not going to be a real slice that I launch, so I don't really care, but I'll try to be realistic. So we recommend you use RFC 1918 addresses here. These are the private addresses, the 10.100s, the 172.16, and the 192.168s, right? Don't use public addresses, obviously, because that's going to break your slice. It's not going to break the test, but you will not have reachability within the slice, likely. Right, there's an option here for a post-boot script. This can be in any language, scripting language that is available on the virtual machine. And that's up to you, right? If you create your own image, you know what scripting languages you put on it. But, I can say, for instance, I can do that. And when the machine boots, I can check, and in the temp directory there will be a file called hello.txt with this line in it. But you obviously can get much more sophisticated with it, and I think in the GIME tutorial you will see some of it. Who still does not have Flukes running? Oh, okay, just a few. Good. All right. So feel free to play around. Don't I'll keep talking about what you can do, and you try same things or try different things. And ask questions if you have questions, right? So don't forget to click OK when you've saved. You can, oh, excuse me, I can't see. You can edit the properties of broadcast links and regular links the same way. You can, if you right-click on the link itself, you can change the name, you can specify the bandwidth, and you can set the label/tag. That's an important feature. Primarily, if you want to have your experiments talk to the mesoscale OpenFlow deployment at NLR. There are specific VLAN tags on each rack that lead you into that deployment. And you have to know what they are. You can look them up on the wiki right now. We have some more automated ways of doing it, but for now that's truly the easiest way to do. So you can specify the tag here, and that will make sure that that slice actually has an exit onto mesoscale. Right? I can show you. Let me just bring up the browser real quick. Sorry. So the entry point for all information about ExoGENI is wiki.exogeni.net. And you click on this experimenters link, and there's more information here. Things like resource types, RSpecs, the different SM addresses. Remember how I mentioned that you can look this up here. Instructions on how to build your own images or where to find existing images. Resource types, right? This explains what type, we know when you ask for this type, what you actually get. And this will change with time. We expect to be a little bit more generous, particularly with cores in the near future. And here are the VLAN IDs. They happen to be the same on the two racks at BBN and RENCI. They will not always be the same, so you have to check, right? You have to double check what rack you want to be using before you put that information into Flux. And let's see. Let me get back to the presentation. So just about everyone should be able to, at this point, try to draw your own topologies and explore the user interface. Does anyone have any questions? Okay, good. So let's talk about the various things. So for each node, you can specify the size, as you saw, the image that it will boot. The domain, optionally, it doesn't have to be there, but if you want that node to be on a particular rack, this is where you specify it. And the post-boot script and the addresses, of course. The addresses are only available if you create links. If you just create two nodes that are disconnected, there is no IP address assignment in that case because they're not connected. That said, just to avoid the confusion, each node, even if you don't link it to anything else in the slice, will have one network interface to the public internet through which you will be able to log in. All the interfaces shown here are additional interfaces in addition to that, right? Node groups, as I said, are similar to nodes. They have a couple more extra options. You can specify the group size, which is the number of nodes that you want in that group, and you can declare them splittable. Let me show you real quick. There it is. So I can say edit properties. I would like 100 nodes. Please don't say I would like 100 nodes, because that's about fills up an entire rack. But let's say you did. If I say it's splittable between domains, do you notice how the list of domains disappeared? That's because splittable means find me some number of racks on which you can place this entire cluster and link them, and optionally link them together if you add the broadcast domain. So it will try to find available resources across multiple racks. And we actually have people who are using this feature for running Hadoop experiments that are larger than an individual rack. One second. Oh, there it is. But that's basically the fundamental difference between a node group and a node. Otherwise, they behave very similarly. Obviously, in the manifest, when you see the slices provision, you see individual nodes. So if you ask for 100 nodes, you will see 100 nodes in the slice manifest. So you can assign IP addresses to the links within the, yes?
Is there a limit on how many links you can have?
Is there a limit on how many links? Yeah. Loaded question. There actually are two limits right now. We're hoping to get rid of one of them. Orca is based on a precise delegation of resources. So when a rack owner joins the GENI Federation, they delegate a specific amount of resources that they are willing to give up to the GENI Federation, and the rest of the resources are theirs, and they define exactly which resources they are. It's in the quantities of virtual machines or quantity of cores they're willing to delegate, the specific VLAN tags they're willing to delegate. So that obviously limits the number of tags, and that's the primary limit. The secondary limit that we're experiencing today is really due to some hardware issues that we're planning to remedy within a month or two. That the reason for that is the VLANs as we create them today are unfortunately software based, and creating each new VLAN places a load on the head node. So the limit is typically quite small. I think we can do maybe about 40 VLANs per rack today in reality. But once that limitation is gone, as I said, in a couple of months, it should be in the hundreds to thousands. And in fact, so there are 3 racks, well, actually there are 4 racks that we will be using today, right? There is the NICTA rack, and the RENCI rack, BBN rack, and the Duke rack. So out of those 3, the Duke rack actually, even though it has older hardware, it has better, in some ways, networking hardware, which does not have this limit. So you can have many, many, many VLANs on it. But the other racks tend to be more sensitive to the number of VLANs provisioned. But as I said, this is a temporary condition which will be remedied. So let me show you one important thing. If you're playing around with the interface, you may be wondering what some of these menus do. You know, this is pretty explanatory. You know, if you want to wipe out your current request, just say new. If you've saved it before, you can open it, you can save it. You can open a manifest, you can say, you know, there's a way to save a manifest, but we don't make it very obvious to do. This is primarily for debugging. This is where you select who you are talking to, the ExoSM or the RackSMs, right? You should have only 2 options. GENI.RENCI.org and the NICTA, which I don't have on the list, right? And that's the property that we edited in the beginning of the session, right? We edited a property in the Flux file, in Flux properties file, which was XML-RPC controller URL, and it's a comma-separated list. So you can add as many URLs in there as you want. So if you want to have all the racks in there, you can do it that way.